So on the assessment for this, you will be allowed to use a calculator. I will give you at least the Pythagorean identities, like sine squared plus cosine squared equals 1. The reciprocal identities I could give you, but I think at this stage you know them by now. And that's what you need to know to answer questions 1 through 3. If you're given sine and you're asked to find cosecant, very simple, just take the reciprocal. Hopefully you know that taking the reciprocal means flipping the fraction. So when you flip 1 over 9, you get 9 over 1. Which is 9. Okay? Just stop me if you have a question. Sometimes a calculator is helpful. For example, number 2. You simply do 1 divided by 0.1044. 9.58. So choice C. Okay. Any questions so far? Good.
How do you do that one?
1 divided by the number. Number 3. If you know that cotangent is the reciprocal of tangent, this is easy. And if you know that taking the reciprocal means just flipping the fraction, you need to rationalize this one. So 6 root 11 over 11. Choice C. Any questions 1 through 3? Great. 4 and 5 are extremely simple if you know what you're doing. So secant equals 1 over cosine only if the angles are equivalent. Like the secant of 15 degrees equals the 1 over the cosine of 15 degrees, but it doesn't equal 1 over the cosine of like 31 degrees or something like that. So the key thing is that the angles have to be equal. For this to be a true statement. So just set the angles equal. This is an angle. Trig functions operate on angles. This is an angle. So 10 theta plus 27 equals 13 theta minus 12. And then it's just an algebra problem. You can think of theta as being x. So subtract 10 theta from both sides. And then you can add 12 to both sides. And that gets you 39 equals 3 theta. Divide both sides by 3, and you get theta equals 13. And that's what they're asking for, the variable. That's it. Okay? Yes, question?
If it had been like sine instead of cosine, let's say, you wouldn't be able to solve that, right?
Not easily. No. So, for example, if I said solve sine of theta equals 1 over cosine theta, that would be a much more difficult problem to solve. And I would not expect you to be able to solve that. So you have to figure out when opposite over hypotenuse equals hypotenuse over adjacent. It's possible, but not easy to do. Good question. Number 5, again, if you get reciprocal relationships, this is a very simple problem. So something times its reciprocal equals 1. Like tan A times cotan A equals 1, because cotan is 1 over tan. So those cancel. Again, the angles have to be equivalent. Notice that I have A and A here. So for this to be a true statement, the angles must be the same. If you know that, it's very simple. Just set the angles equal to each other. Solve algebraically. I know, it's very funny. And you get 13 equals 2 theta. Divide both sides by 2. And this is the number 6.5. Okay, any questions on 4 or 5? Remember, I have you in pairs so you can help each other. Please do so. 6 through 11 just require you to understand where the trig functions are positive or negative. It's the whole ASTC thing. So tangent is positive in the first and third quadrants. So it's not going to be quad 4 or quad 2. Sine is going to be negative in the third and fourth quadrants. So it can't be quad 1. So tangent is positive and sine is negative in quad 3. Any questions on 6? Yes. Tangent is positive in quadrants 1 and 3. Sine is negative in quadrants 3 and 4. You're looking for the intersection, the overlap. So quad 3 is the overlap. It's just a puzzle. That's it. 7. We'll try to make this more interactive. Where is cosine negative? 2 and 3. When is cosecant negative? 3 and 4. Very good. Look for the overlap. It's 3. Easy peasy, lemon squeezy. Okay. What quadrants is sine positive? 1 and 2. Good. Cosine negative? 2 and 3. Very good. Okay, so your overlap there is quad 2. When is cotan negative? 2 and 4. When is cosine positive? 1 and 4. Excellent. So the overlap is quadrant 4. Okay, so see how easy those are if you're fluent with ASTC. Any questions on 6 through 9? (10) and 11, similar type of problem. You need to figure out what quadrant negative 343 is in. Draw something if it helps you. So it's negative, that means it's going down. Negative 90, negative 180, negative 270, negative 360 would be here. So we stop before that. Therefore, we're in quad 1. Quad 1 is the easiest quadrant. Everybody's positive. Next, figure out what quadrant 502 is in. 90, 180, 270, 360, 450, 540, so it would be here. Quad 2 is cosine positive or negative? Negative. How about tan? Negative. Double negative. Any questions on 10 or 11? All right. Next, for these you need to know the ranges of the trig functions. Is it possible for opposite over hypotenuse to be 6.28? No. Hypotenuse is always the longest side. There's no way you're going to get the opposite to the hypotenuse to be 6.28. Good luck. Okay. If the bigger number is in the denominator, this fraction has to be less than 1. And yes, I know technically for our purposes it's less than or equal to 1. Can opposite to adjacent be negative 2.3?
Yeah.
Well,
Yes.
in a right triangle, it can't be negative, but on the coordinate plane, it can be. And that's what we are referring to. So the ratio of the y to the x coordinate can be negative 2.3 to 1. Okay, the y could be negative 2.3, and x can be 1. That's possible. There's no restriction. Another way of explaining this to me is for the number 12, you could say that sine ranges between negative 1 and 1. And 6.28 is outside that range. Tangent has no bound. So anything's possible with tangent. Anything's possible. Secant, can it be negative 0.73?
No.
No. Impossible. Okay. You need to know the definitions. It's hypotenuse over adjacent. Okay, this is longer. So if you have a bigger numerator, then the number is going to be more than 1. Like, for example, 3 divided by 2. It's a number more than 1. Also, you can know this as r over x. And r is always the largest. Okay. Secant either has to be greater than or equal to 1 or less than or equal to negative 1. It's the opposite of sine and cosine. Sine and cosine have to be between negative 1 and 1. Secant and cosecant have to be outside that range. Okay? Cosine, can it be a number like 4/7?
No.
Yeah.
Absolutely it can. Okay? It's a fraction that's less than 1. Adjacent to hypotenuse can certainly be 4 to 7. And then secant is just the reciprocal of cosine. So that makes sense. Plus secant can be a number that's greater than 1. Yes?
For a question like that, when it has two trig functions, is it talking about the same triangle, like, or
Yes,
is it talking
one
about two different triangles?
one could infer because the angles here are
right.
equivalent.
Okay.
Yeah.
So, like, if that had said for secant it was like 10 over 4, then it would be impossible because
Mhm.
they're okay.
Yeah, very good question. Can sine be a number like 0.4?
Yes.
You betcha.
Oh, yeah.
Can cosecant be a number like negative 0.4?
No.
No, it cannot. Possible. Gabe possible. Number 17.
The special ones. What?
We're given cosine. We want to find sine. No problem. I can give it to you. I recommend drawing something. The angle's in quadrant 4. Hopefully you know where quadrant 4 is by now. Let's do something like that. Remember, this still has to do with right triangles. Okay, hypotenuse is 3. Adjacent is 2. Now, you could use Pythagorean theorem to find y, but tomorrow I will ask you to use one of the identities. Okay? And like I said, I will give you the Pythagorean ones at least. So, one of them is sine squared plus cosine squared equals 1. That's one of the ones I will give you. And then it's just plugging in. So we're told cosine. So we plug 2/3 in for cosine, and we square it. What's the square of 2/3?
4/9.
Very good. Somebody knows how to square fractions. I am pleased. How many ninths is the number 1?
9.
9. What's 9 minus 4? 5. Very good. So sine squared equals 5 over 9. How do we get rid of the square?
Square root.
Awesome. Okay, technically it's plus or minus, but we're only going to choose one of them, and it's going to depend on what quadrant it's in. So plus or minus root 5, and the square root of 9 is 3. Okay, so I square rooted the top and the bottom. Now you pick the sign based on the quadrant. You're in quad 4. Is sign positive or negative in quad 4? Negative, very good. Choose minus, since sign is negative in quad 4. So negative root 5 over 3. Okay. I think it is totally natural to ask, why can't we just use Pythagorean theorem? The answer to that question more generally is you could use Pythagorean theorem. You would arrive at the same answer. It's just that I, as your teacher, to assess your ability to use these identities, want to see that you can use them. If you want to use the Pythagorean theorem to check, that's great. It's always good to have multiple ways to be able to do something. And you should arrive at the same answer. But tomorrow I will ask you to be able to use one of these formulas. Okay? Any questions on 17? Find tan if sine is 3 over 4 and theta is in quad 2. So tan is what over what?
Opposite over adjacent.
That's true. What else? Sine over cosine. Very good.
Negative.
Okay. So it's 3/4
Something.
over cosine. So we need to find cosine. I heard Dominique said use sine squared plus cosine squared equals 1. Let's do that. So we have 3/4 squared plus cosine squared. Sometimes I drop the theta. It's just assumed. I mean, we as humans abbreviate. We're abbreviating cosine here. So I think sometimes it's appropriate to do things like that. What's the square of 3/4?
9 over 12.
9 over 16. How many sixteenths is the number 1? 16. 16 minus 9 is? 7. So cosine squared equals 7 sixteenths. And then you just root both sides. So tell me what you think it is.
Well, you say was plus or minus root 7 over 4.
Well done. Plus or minus root 7 over 4 when you square root both sides. And because it's in quadrant 2, we should choose which sign?
Negative.
The negative.
We just found cosine instead of
We did. We're on our way
Oh, okay.
to finding tangent.
Oh.
Negative because quad 2. Okay, moving. We're on our way. 3/4 over negative root 7 over 4.
Multiply by the reciprocal.
Yep. So 3/4 times.
When you have to fix it though,
We'll fix it later.
I can fix the root in the denominator.
We'll fix it later.
Doesn't matter. Genuine smile.
Oh, let's see. Maybe we made an error. Peace out. Peace out. So it's 3 over negative root 7. Now we'll fix it. Okay, let's neuter this thing. Oh, actually, it doesn't matter if I do the negative. I'm going to leave that out. So 3 root 7 over 7, and it's going to remain negative. Is that an answer?
Yeah.
Yes. Any questions on 18?
We're just using identities basically.
You're just using the identities. So it's very helpful in trig to know that tangent is sine over cosine. That was our first step. We are told sine. We need cosine. Math became a lot more enjoyable when I just viewed everything as a puzzle. This is just a puzzle. Now you have to find the cosine puzzle piece. You have this other tool, sine squared plus cosine squared equals 1. Plug in for sine. Square that bad boy. It's 9/16. Subtract 9/16 from 1. It's 7/16. Square root to get to cosine. Square root of 7 is square root of 7. Square root of 16 is 4. We chose the negative version. Technically it's plus or minus when you square root, but cosine has to be negative because the angle's terminal side is in quadrant 2, and cosine is negative in quadrant 2. Then we took this puzzle piece, we stuck it into here, and then we did a little algebra. It's a division, so you can write it as a multiplication times the reciprocal. These 4's cancel, because 4 over 4 is 1. And then you're left with 3 over negative root 7. Rationalize it to follow the rules of etiquette. Negative 3 root 7 over 7. Okay? (19). We're given tangent. The angle's in quad 1. Sweet. That means secant has to be positive or negative. Positive. So eliminate choice A, eliminate choice D. Impossible. Use your reasoning to eliminate answer choices if it's a multiple choice environment. Okay, there's a formula that relates tangent and secant.
1 plus tan squared equals secant squared.
Okay. Tan squared plus 1 equals secant squared. That's one of the Pythagorean identities. It's the Pythagorean theorem written with trig functions, that's all. Easy. Plug in 3/4 for tangent. The square of 3/4 is 9/16. 9/16 and 16/16 is 25/16. Square root that. Five over 4 equals secant. It's got to be pos sour cream,
And done.
like butter. Any questions on 19? So notice, you're just using these formulas and your knowledge of when the trig functions are positive and negative. And you need to have algebra skills. Good. 20. We have a number that has a lot of decimals. So what? No need to be intimidated. We know that tan squared plus 1 equals secant squared. Plug it in, plug it in. See, it's easy. Use your calc. Square away. Add 1 to that. Hopefully that's enough decimals. And then square root. Again, calculator, square root. Such a handy tool. 2.28. $2.281-ish. And it's positive because you're in quad 1. Okay, so hopefully you're seeing how easy it is. I'm giving you the formulas, you're just plugging in, and then making sure that the answer is positive or negative based on what quadrant. Okay, any questions on problems like 20? '21. If I say find cosecant theta given that sine theta equals 4/3, Johnson. Sine cannot be greater than 1. Don't be trying to trick me. Sine theta cannot be greater than 1. The question is, do I recommend completely memorizing the memory check worksheet?
Yeah, I know. I'm having a hard time. I think it's better to
No, it's a valid question. Is that still your question?
yeah, I mean, like,
So here's the deal with memorization. I would definitely prioritize understanding
okay.
over memorization. However,
Yeah, that's
it can be helpful to have things committed to memory like your name. It's helpful to know that your name is Jennifer, so that you don't have to wonder, is my name Jennifer? So it's helpful to know that sine squared plus cosine squared equals 1, to know that, like, to have it memorized, because it just makes you faster. At the same time, I would, to the best of your ability, understand why sine squared plus cosine squared equals 1. And it just comes from the Pythagorean theorem. And here's another word of advice. Sometimes in our academic life, we can't understand yet. We're not ready to understand yet. So the best that we can do is memorize. I've definitely been in that situation. Sure, but in my experience, you cannot force understanding. Understanding comes on its own, sometimes when you least expect it. Okay? There's things that I understood only years later in math. So just do your best. Okay? And also in my experience, frustration is pretty much a waste of energy. Frustration is valid, but I'm not sure it's very helpful. Number 22. What is wrong with the statement secant of 90 degrees equals 1 over cosine of 90 degrees? You can't take the secant of 90 degrees, that's true. And cosine of 90 degrees is 0. And you cannot sit on 0. So, I will say something that, like this. Although it is true that the secant of theta equals 1 over the cosine of theta, cosine of 90 degrees equals 0, and you cannot divide by 0. So, like, if somebody were to ask you what's the secant of 90 degrees and you try to use your calculator, and the calculator doesn't have a secant button, so you do 1 divided by the cosine of 90, the calculator says divide by 0. But the person who's assessing you is probably going to expect from you not an answer like, my calculator gives me an error. They are probably going to expect from you an answer for secant of 90 degrees of undefined. Any questions on 22?
Nay.
23, true or false? Ooh, a 50% chance. Since tan is sine over cosine, which is true, if tan is 1 over 3 with theta in quadrant 1, then sine is 1 and cosine is 3. False. Why? Cosine can't be greater than 1. Easy. So what that means is that the ratio of sine to cosine reduces to 1 to 3. It doesn't necessarily mean that sine is 1 and cosine is 3, and it's actually impossible for cosine to be 3. Okay? Next, 24. If for some particular angle, theta, sine of theta is positive and cosine of theta is negative, in what quadrant must theta lie? What is it? What quad? 3? I'm going to go with 2. Positive sine, negative cosine, quad 2. What's the sign of tan in quad 2? Negative. So it's just a Santa Claus problem. If secant and cosecant are negative, what quadrant? Anyone? 3, right? What's the sign of cotan? Positive. And then if an angle has an undefined cosecant, what other function must be undefined? Cotangent. I gave you this hint before. I will repeat it because I think it's very helpful. Tan and secant go together.
How do they go together?
I'll explain. Cotan and cosecant go together. They go together in two senses. One, where they are undefined. And two, I'll just write it up here. In the Pythagorean identities. For example, tan squared plus 1 equals secant squared. Tan and secant go together. And cotan squared plus 1 equals cosecant squared. Cotan and cosecant go together. But I'll provide you those. Cosecant has what in the denominator? Y, right? And cotan is x over y. So on the x-axis, y equals 0. So cotan and cosecant are undefined. Any questions there?